Hello friends, first of all welcome to my video lecture. I am Professor Deshmukh. Today we are going to discuss a topic which is named as Microcontroller 8051. In this video we will discuss the feature, block diagram and architecture of 8051 microcontroller in detail. Okay, we will start with the features of microcontroller 8051. It has 8-bit processor, which means it can process 8-bit long data. Okay. Next one is it has 4K ROM. ROM means, we know that ROM means read only memory, and 128 byte RAM. RAM means random access memory. Inside it, if we need more memory space, then we can connect external memory to the microcontroller. Okay. Then it contains two 16-bit timers like timer 0 and timer 1. Timers are used as counters or for delay calculations. Both the timers operate independently. Okay. Next one is for input or output ports. 8051 has 4 input or output ports to connect 4 input output devices to it. But when we need to use external memory, then 2 input or output port are used as address and data bus for memory. Serial devices can be connected to it through one serial port. Okay. 8051 microcontrollers support 6 interrupt sources like 2 external, 3 internal and 1 reset, which includes 2 external interrupt, 3 internal interrupts and 1 reset. Normally reset is not listed under the category of interrupts, but if we observe the function of reset, whenever we reset microcontroller and microcontroller switches to its initial condition, that is microcontroller is interrupted by reset signal, and so it is listed as interrupt source here. Okay. Lastly, it has an on-chip clock oscillator which needs an external clock to run it. Okay. Next is, now we will discuss the block diagram. All the features discussed in the previously slide are present in this diagram. Okay. In this diagram we can see CPU, oscillator, bus, on-chip ROM, on-chip RAM, timers, input output ports, bus control, serial port and interrupt. Okay. First of all, it has a CPU, that is central processing unit, whose responsibility is to control all the operations. Okay. CPU need a clock for operation. In fact, whole microcontroller work on the clock, and 8051 has a on-chip oscillator which provide clock for the CPU to execute all the operations. This oscillator require a piezoelectric crystal to provide external clock. Internal connections of all the block in the chip is represented by this bus. Okay. Next is, it has on-chip ROM. It stands for read only memory. ROM is used for storing the program, and so it is termed as code memory. And on-chip RAM to store the data required for operation, and hence termed as data memory. Okay. As discussed in the last slide, it has 2 timers, 2 16-bit timers, timer 0 and timer 1, plus it has 2 counter input signal. When timer work as delay device, they will they use internal clock of the microcontroller. But when timers work as counter, two external counter clock inputs are provided for counting. Okay. Next block is input or output ports. It has 4 input or output port, P0, P1, P2 and P3. If we are using external memory with the microcontroller, port 0 and port 2 are used as address and data bus. Okay, shown in this figure. Next is, in case of external memory interfacing, the bus control block provide control signal. For using external memory, the signal are PSEN bar and ALE. I will discuss them later in pin diagram. Okay. Next, serial device can be connected to this processor using the serial port TXD and RXD, that is transmit data and receive data. TXD to transmit the data from microcontroller to serial device and RXD to receive data from serial device to microcontroller. Microcontroller has interrupt control block to support two external interrupt. So far we have discussed block diagram of microcontroller 8051. Okay. Now we will discuss detailed internal architecture of 8051 microcontroller. In this diagram, power and ground is, let us see, first is the power and ground, next is timer and control unit, instruction registers, oscillator, port, latches, RAM and other registers are present. Okay. First, to start with, we have power supply and ground. Okay. Power supply and ground connection of the IC, which are very important signal to run the microcontroller. The next block is time and control unit. It is an important block as it generates control signal and control all the operations performed. You can see 4 signal in that. First is PSEN bar, EA bar, ALE and RST. RST is the reset signal. A high signal and RST take microcontroller to its initial condition. Rest of the signal are used when external memory is interfaced with the microcontroller, which we will discuss later. Okay. Then we have instruction register. Instruction register fetches the instruction, store it and decode it, and accordingly control unit generate control signal. Okay. On-chip oscillator is also shown in figure, connected to external crystal to provide clock to the system. Next two blocks are port 0, port 1, port 2 and port 3. As we discussed earlier, all are 8-bit ports. You can see P1.0 to P1.7, similarly P0.0 to P0.7 and so on. Okay. Latches and drivers are connected to all the ports. In that, latch is used to program a port, that is to make the port input or output, and drivers are required to provide current to output device. Drivers are basically buffer or current amplifiers. Drivers are required to drive the port when working as output port. Then we have RAM and RAM address register. This register provide address to the RAM for reading and writing operation. That is, RAM address register enable one of the location of the RAM. Then we have ROM or read-only memory where program is stored, and similar to RAM, it get its address from program address register, so that program can be executed from particular ROM location. The content of this program address register are updated by program counter, which is a 8-bit register. Which is a 16-bit register. Program counter contain the address of next instruction of the program, which means the address of the next instruction to be read from ROM is in the program counter. PC incremented register is responsible to update the content of program counter according to the execution of the program. Okay. Next is register. The most widely used register of the 8051 microcontroller are accumulator, means A, B, R0, R1, R2, R3, R4, R5, R6 and R7, and DPTR means data pointer, and PC program counter. Okay. All the above register are 8-bit except DPTR and the program counter. Then we have DPTR, that is data pointer register. Mostly when we are dealing with external memory, then DPTR, that is data pointer, contain the address of the external memory. DPTR is a 16-bit register. Rest all register are 8-bit register. The reason for it is microcontroller can access 64K external memory. 64K memory access requires 16-bit address. Okay. DPTR is actually combination of two 8-bit register, DPH and DPL. Then we have register B. It is a general purpose 8-bit register. It is used in conjunction with accumulator register in divide and multiple operations. Okay. Accumulator is a 8-bit register and take active part in ALU operations. ALU stand for arithmetic logic unit, responsible for all the operations performed by 8051. The result of operation is stored in accumulator. ALU takes input operand from temporary 1 and temporary 2nd register. Based on the result of operation, it updated flag present in PSW register. Okay. PSW stand for program status word. Accordingly to the result, flag of PSW register are updated. Okay. Lastly, the block is for interrupt, serial port control and timer control. Microcontroller has 2 timer, 1 serial port and interrupt, which are controlled by this block. SFR stand for special function register. SFRs related to timer, serial port and interrupt control are stored here, which are actually a part of RAM. SFR stand for special function register. This diagram covers the internal architecture of 8051. Detailed discussion on each block we will cover later. Thank you for watching this video.